Hi geometry students, today we are going to start looking at surface area and volume of different figures. So if you haven't already on our calendar, go ahead and download the surface area and volume packet. You can see that this is the first page that we have, and this is actually the notes that we are going to be using for the rest of the year. So we actually do have a couple of weeks of material. It's really looking at lesson 33-1 and going all the way up until 37-2. It's actually quite a couple of pages in the textbook. It's about 60 pages, but what I decided to do was compile it together into a little bit of an easier to organize packet, so that way we're not kind of jumping around with too many different figures, but that we're able to break up surface area and volume into different parts. If you head to the next page, you can kind of see our table of contents here. So for today's class, since it is this date, we are going to be looking at our first lesson, lesson 1, looking at solid geometry and formulas in 3-dimensional. Now, it's going to be kind of the first couple of pages, and we're going to continue on with the lesson tomorrow, but it's mostly going to be our introduction, focusing on ideas from activity 33-1. And as you can see, I kind of have an outline of us, what we're planning on doing over the next couple of weeks, and each lesson is going to take a day or two to go over, depending on how we split it. But you can see down here at the bottom, we are going to be having our fluency check on Friday, 5/14. So plan accordingly for that. All right, so we are going to start off on page 1, so you can find it at the bottom right-hand corner, right after our table of contents page. But we're going to start looking at lesson 1, so solid geometry and formulas in 3 dimensions. So we're going to start off looking at our prism first. So I started to kind of uncover and write some things down. You can see over here, I'm going to try to color coordinate the different terminology that we fill in here with our example. So we're going to start off with saying a prism is formed by 2 parallel, congruent, polygonal faces. And those faces are actually called bases. So we can see over here that we are going to have in this picture, these 2 triangles are going to be our bases. Now they are connected by lateral faces that are rectangles. So we're going to see that this is going to be called a lateral face. And if we kind of envision that aspect back there, it's a little bit hidden, and there's another one back there too, but we can see there are 3 lateral faces. Now the cool part about this prism is a prism is named by whatever their base is. So here we're going to add that kind of down to the bottom. So go ahead and add that a prism is named by their base. And we're going to name the example on the right side. It's going to be called a triangular prism. So now we can go ahead and start to look at our next shape below. So we're going to go ahead and look at our cylinders. So we can see over on the right, I kind of shaded what we now know as the bases, right? And we can kind of see that there's this curvature around these circular bases. So looking at this, we're going to see a cylinder is formed by 2 parallel congruent circular bases this time. And there is a curved surface. We can see that there's a curved surface here, right? That is going to connect both of our bases. Now, going on to our kind of next introduction of our solid geometry figure, right? We've looked at prisms, cylinders, just a nice introduction of them. Now next, we're going to look at a pyramid, which we probably are very familiar with. So we see we have this visual off to the right. We can see that we actually only have 1 base. So our other 2 figures highlighted in pink were our 2 bases. This one only has 1. But at the top, there is a point that's called the vertex. So looking at a pyramid, it's formed by a polygonal base, and it will have triangular bases. So they are going to meet at a common point that's called the vertex. So something about pyramids too, just like with our prisms, is that they are also named by their base. So in this one, again, we have a triangle as our base down here. So that means the name of this is going to be a triangular pyramid. And then last but not least, the other image that we are going to start looking at that definitely has a little bit of some sides to it, a different shape. We're definitely going to get to spheres in the future, but we're really going to focus on these 4 shapes here. So we're going to look at cones. So that good old ice cream cone, right? So we can see we have it here, but it's a little upside down. So again, just like the pyramid that we had here, there's really only one base, but we do have our sides coming together at a common point, a common vertex. So our cone is going to be formed by a circular base this time. And there is a curved surface that we can see, just like we had with the cylinder, but it's going to connect the base to our vertex. So again, we're getting an introduction to these 4 vocab words. Looking good so far. And you can kind of see I'm trying to color coordinate some of the vocab, not only in the definitions, but with the pictures that are there. So now we're going to go ahead and look below, starting to address more vocabulary, specifically polyhedrons, but also looking at faces, edges, and more about the vertex. So these are different parts that make up our 3D shapes. All right, so down here below, I also did kind of color coordinate this figure, so that way we can kind of look at it and see what different aspects we can label. So I know these 2 sides here, and ironically, along with this place right here, those are actually flat surfaces. So those are actually going to be our faces. So for the definition of a face, it's going to be each flat surface. Now, we're going to learn there's actually multiple types of faces. They actually are called base or lateral. So if we take a look at this, we actually have 3 kind of different faces that we're looking at for starters. If we just imagine that this is kind of an open box. So we can see that there is a face here, as well as a face here. Now, keeping in mind, when it's our base, right, we know that those are most likely going to be kind of 2 parallel sides to each other. Kind of referencing our previous vocab terms, right? We had our prisms and cylinders. They had 2 parallel bases, right, that were congruent. So we're going to call these 2 pieces here, we're going to call those faces, but they are specifically focusing on the base. So I'm going to go ahead and label both of those. Again, there are more that we can find in our picture, but I just wanted to show you the 2 so that way you can see that they are going to be parallel to each other. And if you come looking down here, this is actually going to be our lateral face. Now, the reason for this is because think about this. There are 1, 2, 3, and if I pull on the other side, 4 different faces that kind of go around and connect the 2 base faces. So that's why we know they're not going to be base faces down here. That's why they're lateral, because there's more than 2, right? These 2 are going to be congruent and parallel to each other. So again, we know that this is a face. All right, so we're going to also move on to our edge definition. So we're going to write down that it's a segment that is the intersection of 2 faces. So there's actually a lot of edges kind of in this figure, and maybe we've heard this vocab before in everyday language, but an edge is when 2 faces intersect. So I actually labeled this edge right here. There's a couple of others, but like I said, that's an example of an edge. Now let's look at our vertex. Kind of already saw it in our vocab above, but we can kind of see it's really our point of intersection, but it's going to be a little bit different than our edge. It's going to be our point of intersection of 3 or more faces. So if you looked up above, looking at our pyramid, we saw our picture up at the top here had our vertex, the intersection of 3 or more faces. So right here in our picture, this is going to be a vertex. So we can go ahead and label that because it's the intersection of at least 3 faces. We do have 3 in this picture, but it could also be more. So we have some nice vocab and a visual to help us out with that. Now let's keep going. Let's go ahead and look at our polyhedron that's right here, that definition. So it is actually formed, a polyhedron is formed by 4 or more polygons that intersect at their edges. So what we're looking at really, it consists of segments and no curves. That's kind of what we're looking at. A polyhedron is formed by 4 or more polygons that intersect at their edges. Now, granted, this doesn't have to be 4 different polygons. Just thinking about our picture before, right? We have at least 4 general polygons that are formed here, and these are all segments. There are no curved edges. So let's go ahead and look below here and figure out how not only can we name the following 3-dimensional shapes, but then we're going to decide if the solids below are actually polyhedrons. And if they are, we're going to count the number of faces, vertices, and edges of each of the polyhedrons. Do not worry, that's going to help us out a little bit later tomorrow when we start to approach practicing labeling vertexes, edges, faces. We're going to look at something tomorrow called Euler's theorem that looks at the relationship between faces, vertices, edges, and then we're going to do a little bit of practice in describing our 3-dimensional figures, possibly from a net. So we're going to learn what that is tomorrow. So for today, we're going to finish up looking at example 1 and just finish the first page. So looking at this, let's see our first example. Obviously, you see I can kind of help you out with this. I actually highlighted the bases for you already, as you can see. And maybe you saw above, wait a minute, it kind of looks like one of our previous examples. Right, maybe some of you looked up here before and saw, wait a minute, it's like a triangular prism, but on its side. So you're correct. It doesn't have any curved edges, so we know that this is a triangular prism. So it is a polyhedron. So now we have to label the faces, edges, and vertices. So I want you to pause the video right here, and I want you to see if you can count up how many faces, edges, and vertices there are. All right, so let's go ahead, figure out how many faces, edges, and vertices there are. So here's what I ended up getting. For faces, I can see that there are 5 different faces because I have 2 bases, and since it's triangular, I have this, the bottom one, and the other side. So that's 2 plus 3, so that's how I get my 5. As for edges, this one can be tricky. There are actually 9 different edges if you start to look at all of these pieces kind of put together. So something you can see is this is an edge, this is an edge, this is an edge, this is an edge, so that's 4 already. We have 5, 6, 7, 8, and then 9 across the top. So keep in mind, edges are different than faces, right? And then vertices. How many points are there all together where there are at least 3 or more faces? I got 6 because it's really 1, 2, 3, 4, 5, 6. So hopefully you got close to those results. If not, we're going to get a little bit more practice. So let's go ahead and go on to part B. Let's figure out what's the name of this shape. Obviously, you can see it's a cylinder, and unfortunately, we want no curved edges, so we know that this is not a polyhedron. Remember, because, polyhedrons have no curved edges. So we really can't count the faces, vertices, and edges if it's not a polyhedron. Let's look at part C. So we can see I kind of highlighted what my base is down below in that same color. Obviously, you also see that there are all segments. There are no curved edges, so we know it's a polyhedron. But start thinking about, how this looks like a pyramid, but think about how we name pyramids in regards to their base shape, right? So we can kind of zoom out, look at what we saw, or essentially move up, look at what we saw before and saw that they are named by their base. So whatever the shape of our base is. All right, let's go ahead and look at that. So the shape of our base here is 1, 2, 3, 4, 5, 6 sides. So really it's a hexagonal pyramid. So let's go ahead and write that down, a hexagonal pyramid. And yes, it's a polyhedron, so that's looking good. And then we want to figure out how many faces, edges, and vertices. So go ahead and pause the video again right here, and then we're going to come up with and see if we get the same number. All right, let's start off with faces. We know there's 1 at the bottom, and technically all of these make up 6. So I'm going to conclude that 6 plus 1 is going to give me 7 faces. As for edges, right, we know there are guaranteed 6 down at the bottom here, but then remember we have to count these as well. Those are edges as well, so it's 2 faces being put together. So if we count all those line segments, we get 6 as well. So 6 plus 6 gives us 12. And then last but not least, we want to count the vertices. So all of these points that have at least 3 faces. So I have 6 points here, but don't forget this vertex up here. So 1 plus 6 is going to give me 7. So I have 7 vertices. And then let's look at our last problem for today over here. We can see that, oh wait, there is a curve, right? This is technically a cone. It's like our ice cream cone, right? We could have a ice cream scoop sitting on top there. So we know that this is a cone. It's not a polyhedron, unfortunately. Womp womp. All right, so we were able to finish the video notes for today. Make sure you're writing these down, copying these down. Again, you can pause the video at any time if it's moving a little bit too fast. Make sure you can, realize that you can go back and hear something again that I explain it. But keep in mind, I actually am going to be collecting all of these notes. That's right. Maybe I should have said this at the beginning of our lesson, but it's really important and imperative that you are actively writing this down, because honestly, these notes are going to count as your homework grade and that homework completion. So you can go ahead, make sure that you're going back and writing everything down. Tomorrow in class, we are going to finish up lesson 1. So we're going to look at page 2, talk about any questions that you have on this still. So make sure to bring those tomorrow. And I hope you have a great rest of the day, and I will see you tomorrow.